Hi everyone, I thought I'd just really quickly go through the check for understanding problems today and solve them myself so that you could see an illustration of their solution. So first it says eliminate the parameter to find a Cartesian equation for this set of parametric equations. So I've got that x is t over 3 plus 2 and that y is root t. So I think I'm going to try and isolate t here so that I can plug in for x over there. So first I'll subtract 2 on both sides. So x minus 2 equals t over 3, and then I'll multiply by 3 on both sides. So that gives me that t is 3 times x minus 2, and then that's what I plug in there. So it gives me y equals root 3 quantity x minus 2. And a lot of people wrote 3x minus 6, which is also fine, because it is algebraically equivalent. This question asks, what transformation is the same as shifting your entire path left by 3? So what we want to do is we want to take the x coordinates and we want all of them to be 3 smaller. So you wouldn't do either of these because these are both transformations on the t variable, which is time, before you figure out what x coordinates there are. So these two don't transform x at all. So these are the only two which transform x, and one takes the x coordinate and makes them 3 smaller, and the other takes the x coordinate and makes them 3 larger. So this would be the correct answer for shifting left by 3. Some people noticed that this is backwards from how you think about horizontal transformations in a Cartesian coordinate system. If I've got y as a function of x here, and I want to shift this whole curve to the left by 3, in that case, left by 3 would involve replacing x with x plus 3 on the inside. And so people were kind of observing that those seemed different. I'm going to record a video about the details of why for next class, but it was a good observation. This problem asks you, again, to find a Cartesian equation. And this is like the problem from the problem set where I encouraged you not to isolate t. Because here, if I want to get t by itself, I'll have to take the inverse sine of both sides, and then I'll have to plug in, and it's going to be a mess. So what I'm noticing is that there's a sine t that occurs in both expressions. I've got x is root sine t, and I've got y is just 2 to the sine t. So again, if I want to be able to substitute x inside the y equation, I'm going to try and isolate the expression that has t in it here. So I'll square both sides, and I've got x squared is sine of t. And now I'm going to stop. I'm not going to try and isolate t further because I already have a sine of t over here. So the equal sign means that the thing on the right is the same value as the thing on the left. They're interchangeable. So I can replace sine t with x squared, and that gives me 2 to the x squared. And that would be the correct answer. All right, so which of these parametric equations, which I'm going to show you right now, which of these parametric equations represents a motion from the right to the left is the question. So if we want to know if something's moving right to left, you know that the graph of x as a function of time should be decreasing, because that's literally what it means to move from right to left. It means that as time increases, the x coordinates are getting smaller. So all you have to do is, so you don't have to look at the y parts at all. You only have to look at the x parts. So this is 2t minus 9. I know that's a line, and I know it's got a positive slope. So because it has a positive slope, that means that the x values are increasing as t goes up. So that's not 1. 10 minus t, that's a line, and the slope is negative. So I know that that one's going to work because as t goes up, the x-coordinate should be decreasing because of the negative slope. When x is root t, so root t looks like this. So that definitely doesn't involve decreasing x-coordinates over time, so that's not it. 1 over t for values of t larger than 0. So 1 over t looks like this. And this also seems to fit the requirements. As time goes up, the x-coordinates are getting smaller and smaller. So that's another one that would represent a right to left motion. And then the last one is negative t, which is, again, just a line with a negative slope. So those three all represent motions from right to left. All right, let's choose a time interval when the object is moving left. So as I just said, that involves an interval where the x-coordinates decrease over time. So the interval from 0 to 1 would do it, and the interval from 3 to 5 would do it, either one of those. So technically 3 to 4 counts, but that doesn't cover the entire interval. So I'm going to do 0 to 1 because that does cover the entire interval. If you said 3 to 4 and it marked you wrong, you can think about, like, you got that problem right because you understood what was happening. So choose a time interval where the object is moving down. That would be where the y values are decreasing. So that happens from, it looks like time equals 1.5 to time 3. I don't see any time intervals that match that, though. So I'm going to say none of the time intervals fit the description. So choose a time interval where the object is in quadrant 3. So let's think about what do we know about quadrant 3. For the normal Cartesian plane, this is quadrant 1, 2, 3. So quadrant 3 has negative x values, so x is less than 0, and it has negative y values, so y is less than 0. So I want to find a time interval when x and y are both smaller than 0. So it looks like for x is only smaller than 0 from time 4 to time 5. It looks like y is also smaller than 0 from time 4 to time 5. And it's certainly true that the y values are increasing, but they're still negative. So because that fits, I think time 4 to time 5 is a time when the path is in quadrant 3. Let's choose a time when the object crosses the y-axis. So crossing the y-axis means that the x value is 0. So it looks like that only happens at one time, at time equals 4. Choose a time when the object isn't moving up or down at all. So I can see in the y versus time graph, the only time when the y-coordinates or the only interval for which the y-coordinates don't change is the interval from 3 to 4. So that's the one I'll choose. All right, so the last question is, which sets of parametric equations represent y equals 3x minus 1? So as we said in class, a Cartesian equation like y equals 3x minus 1 is telling you a relationship between x coordinates and y coordinates. So if our x coordinates are calculated as a function of time and our y coordinates are also calculated as a function of time, we need that same relationship to be true. So whatever equation we're using for x, the way you get the y equation is you take that same x equation, you multiply it by 3 and subtract 1. Because that's guaranteeing that whatever number comes out of the x equation, you're going to end up with the correct y value for this line for your y function. So let's take a look. Here we've got when x is t, y is 3t minus 1. And that definitely seems to fit that relationship. So what about when x is 3 minus t, y is 3 times that same thing minus 1. 3 minus t minus 1. So that also seems to work. So the first two work. Here I've got when x is sine of t, y is 3 times sine of t minus 1. And that also seems to hold the same relationship. So that one also works. The last two, we've got x is 3t minus 1 and y is t. So that seems like it's the reverse relationship. That doesn't make sense. And then for the last one, we've got t squared. So you would expect over here to see 3t squared minus 1, but we don't. So the last one doesn't work either. So something that we'd also talked about was if your function for x, if the range doesn't cover all real numbers, then that means that you're never going to visit some x values, which means that you're imposing a domain restriction on the Cartesian path here. So like this one, for example, sine is never larger than 1 and it's never smaller than negative 1. So even though this parameterization of the line lies on top of this curve. It's this curve, but with the domain restriction that x is between -1 and +1. So if you left this one off for that reason, then no problem. Like, that still makes sense. Oh, and I guess that's the end of the problems. Okay, well, I hope this was helpful. If you still have questions, please come to the office hours. Thank you so much.